Hello. So as we make our way into this chapter, you're going to see that we're going to come across the idea of logarithms. So if you've seen this before, then great. But I want to make sure that we just have at least a review of the relevant concepts, the basics that we need to be able to solve some of these equations. So let's just start off with what is a logarithm. So imagine we have an equation and our variable that we're looking for, that we're trying to figure out, is in the exponent. Well, how do we solve this type of equation? Well, something like this, where I'm saying 5 to some power is equal to 25, sometimes we just know the answer. Because if I were to think about this, I'd be like, well, I know that 5 squared is equal to 25, because 5 times 5 is 25. Well, then that means my x must be equal to 2, right? Because that's what the exponent is, that gives me 25. But what if we started seeing something where it's not as straightforward? Like this one right here. What if now instead of equaling 25, which is a perfect square, I were to ask you 5 to some power is equal to 45? Well, now we may be a little more stumped here because I'm thinking 5 squared, that's 25, that's too small. 5 to the third power, which is 5 times 5 times 5 would be 125, that's too big. So my answer has to be somewhere between 2 and 3, some decimal. But I'm not sure what that number is. Well, luckily, our calculator can actually do these things, right? If we have a scientific calculator that can calculate these, we can use what's called a logarithm. And so what does a logarithm tell us is really, it tells us what's the exponent. It answers that actual question. What's the exponent on 5 that gives us 45? So that's what we're looking for. What is the exponent? So another way of kind of making it look a little more mathy, I might be saying, what's the exponent on 5 that gives us 45? And that would give us the answer for this question here, for this equation. Well, rather than writing it as this form, we don't use the words exponent on, we use the word logarithm, which means exactly the same thing. When I say what is the logarithm, we're just saying what is the exponent on. And this is the form that we write it in. So when I see log base 5 of 45 as we read this, this is just saying what's the exponent on 5 that will give us 45. And let's use a calculator to just give us our answer. So I'll just use Desmos here, and I'm going to type this in, or you can just kind of look through it on here. But I'm going to say, what's the exponent on 5? Right, so don't worry about how to type this in right now for you. And notice what it gives us. It tells us the answer is 2.3652123, and I'm sure it goes on for more, but it's rounding off to this many decimal places. So if we were to just round this to, 4 decimal places, we can see that this would be 2.3652. And there we go. So answering this question here, what's the exponent on 5 that gives us 45? Well, that exponent could be found using the logarithm on the calculator. And we see that 5 to the 2.3652 power is about 45. So here's one problem though. I know I was using Desmos here to help us out, and I was able to tell us this exactly as I wrote it here. But a lot of times, many calculators don't have the base. So for example, here, our base was 5, right? I want to say, what's the exponent on 5? Many calculators tell us is, what's the exponent on a base of 10? And also a number called e, but we'll just focus on 10. And so when we do this, we see that there's actually a special way that we can write this, because we call this common log when we're using base 10 rather than any other base. So rather than writing this as log base 10 of y, meaning what's the exponent on 10 that gives us some number y, we can just leave off the 10 and say log of y. And again, the way we interpret this is what's the exponent on 10, the invisible 10 here, that gives us y. So, for example, if we were to have this equation here, 10 to the x power is equal to 45, and I wanted to know what's the value of x, well, I can figure out x because x is the exponent on 10. So we're just saying what's the exponent on 10, which we just write as log, that gives us 45. And you'll see that rather than having to type in that little base here, other calculators, such as the scientific calculator on Desmos, can now do this. And again, you can just type in log, or if you look under functions, you will probably find that log right here, where it says log. And you notice it doesn't put in the 10 here, but I can just type in 45, and it gives us the answer, 1.6532. So then we can say that x is 1.6532. And so if we took 10 to this power, we would get about 45. So this idea of using logarithms is going to be useful for us in solving equations, as you can see, because now we have the ability to solve for an x that's in the exponent, or any variable that's in the exponent. There's one other property that's going to be useful to us for logs, especially when we aren't using base 10 and we only have base 10 on our calculator, and that's the exponent property of logs. So what does the exponent property of logs tell us? It tells us if there's an exponent and we take the log of it, we ask what's the exponent on base 10? Well, it doesn't matter if this is a base 10 or base y or base 5 or any base that we want. What the property tells us is if there's anything in the exponent already and we take the log, well, we can just move that to the front, right? So raising it to the a power here would mean the same thing as just multiplying it by that number in front. Because if you think about what a logarithm is, it's just asking what's the exponent. So if there's an exponent on there, on another exponent, well, one of the properties we saw is you can just multiply. So this allows us to just multiply by anything that's already in the exponent. So here's a quick example here so you can see how this works out. If I want to take log base 10 of 100 squared, right? So yeah, we can just type this into a calculator as we want, but let's apply the property. Because this 2 is in the exponent, I can move that to the front. And now we have 2 times log of 100. And if we think about what this log of 100 is, again, this is just saying what's the exponent on 10 that gives us 100. Well, you might remember that 10 squared is 100. So this logarithm that's asking what's the exponent would just be the exponent of 2. So this would become a 2 here, which now we get 4. So the log of 100 squared is 4, meaning the exponent on 10 that gives you 100 squared would be the exponent of 4. Let's look at one more example, and this one we're going to see how it's useful now to be able to solve for x when we don't have base 10. So solving equations, we always want to get our variable by itself. So in this case, since our x is in this exponent, let's just solve this as we normally would. I'm going to do plus 3 to get that 5 to the x power by itself. And here, 24 plus 3 is 27. And here is where our log is going to become useful. It's base 5, so it's not base 10, but we're still just going to use base 10. And so in order to be able to get this x, which is in the exponent, be very careful. A lot of students want to divide here, but division doesn't work because this is not multiplication, it's an exponent. So the way we get that exponent down is, again, just as we just saw. We're going to take the log on both sides. So I'm going to type or write the word log on the left side. And we're going to put the log on the right side because, as we know, what we do to one side of the equation, we have to do to the other. And when we put these in, the left side becomes the 5 to the x inside here. And the 27 is in here. Well, the property we just saw says that, hey, this x right here, if we can take that out of the exponent now and put it down in front. So this is going to be the x down in front now. And it's times log of that base is equal to log of the 27. And now because the x is out of the exponent, we're able to now solve the rest of this equation. Because if I want x by itself and we're multiplying by log 5, we can just divide by log 5. And when we do this, we get x is equal to log of 27 divided by log of 5. And doing this on a calculator, if we wanted to turn this into a decimal, well, let's find out what we get. If I did log of 27 divided by log of 5, I get 2.0478. And there we go. So again, we see the process of how do we solve for a value that's in the exponent is we can use the logarithm to bring that exponent out of that variable out of the exponent, and then we can just use a calculator to do the calculations.